Alright, so we are back here on this electric gator. We got our new motor speed sensor in place, and this is our old one. We got our battery voltage, well, 14-15 volt in on the red. We got our 5 volt supply. We got our ground. And then we got this little magnet here that sits on the end of the shaft. And we can see it's all cracked in multiple spots. That sits under the cover, bolted to the shaft. Generally this happens because of heat. But, so we got that replaced. And this one is, there will be no motor calibration on this one. This one is an older Curtis controller. It doesn't have that capability. So we plug in there. We got our Curtis 1311 user level access. There are, oop, come on, focus here. You got your 1101s, your 2201s, and your 33 or 4401. They're all different levels of programming ability. So there's your part number. These are the most readily available and they'll do the job. So we got a couple options here. Faults were all cleared out. We had our speed sensor fault, our 1.3. So here's our monitor. Throttle, battery voltage, heat sink, armature current, field pulse width, armature pulse width, speed in. So the one we're really concerned with right now is speed in. So, bear with me a second. And break off. We now have a speed input. And if we watch the screen here, hopefully you can see that. Good 0 to 5 volt square wave, and let's, hopefully we caught that. No, we didn't. Oh, we got enough. I already got a good capture of this anyway, but standard speed sensor, pulling down, amplitude or frequency changes with speed. So that's good, and that is part of your post-repair documentation. If you don't have a known good on something, take your post-repair, your pre and post, your known bad, your known good, save them, document them. So, what else can we do with this? So, let's go and watch to see how some of this regenerative braking works. So we're really going to worry about our pulse width here, armature and field. That was being defaulted to 30% duty cycle with our speed sensor fault. And then our current is our input current to the armature, field current. I should say armature current draw, not input, but. And then if we go here, try to keep you guys focused. Notice how we go to negative armature current. That's actually the regenerative function of the motor starting to put current back into the batteries. And we'll just show you one other function here. It's easy now. So we're going up on the loading dock here. We're going to pop it in neutral. And then notice here, it's still applying armature current and all as we're creeping downward. So it's using the motor controller to act as a secondary braking mechanism on the whole machine. So, quick, easy, simple post-repair verification. Like I said, this one does not have any programming functionality within the motor controller. One other thing we can do, function settings. Every time you plug this controller in to this motor controller, it automatically saves whatever data is written to it. And then we can reset the factory. If somebody was in there on a newer style motor controller messing with it, we can reset. We can write the settings that were saved here to it. As long as this is plugged into power and we don't cycle the key switch or disconnect this, it'll save all the current settings. So if this was a configurable one, we could go in, we could play with all sorts of parameters, start, stop, acceleration rates and all that. And say we got it all wonky and it's not right, we could easily go back to our default settings. So once again, that is the Curtis 1311 1101. A couple variants of it out there. These are used, actually, if you do a little research, these are used on all sorts of electronic motor controllers. So it might be, if that's something you get involved with and you don't have one of these, it might be worth it for you. So that's it. We're gonna go drive around quietly for a while. Hope you enjoy it.